1. Okay, so here we have a problem regarding about heat pump. Another problem. Here, for example, we have a house which is built so that the heat loss will be at a rate, this rate, 5,400 kilojoules per hour per degree Celsius difference between the indoors and the outdoor temperature. A heat pump that requires a power input of 6 kilowatt is used to maintain this house at 21 degrees Celsius. Determine the lowest outdoor temperature for which the heat pump can meet the heating requirements for this house. So for example, let us try to draw the house. So ingon ang imong house, no? The house must be maintained at 21. Okay? However, this is not really fully insulated, and therefore to maintain this at 21, namang kay dili ni siya ma-maintain, no? It's impossible for this house to maintain its temperature alone kay imuhang ang surrounding temperature nimo kay usually lower man at 21. Therefore, na kay heat, no? Heat will escape from the house towards the surrounding, and kana nga heat, kana nga pag-escape sa mga heat diyan, daghan sila nga heat, ang ihang magnitude is this one. Kana nga Q nga loss, no? Q that will escape from the house is equal to 5,400 kilojoules per hour and per degree Celsius. So meaning ani nga kuan per degree Celsius. Per degree Celsius difference between the temperature of the house to that of the surrounding, no? Shall we say, dili ba kabalo man ta nga ang surroundings nato ani is usually colder sa imong house. So let's just call the temperature of the surroundings TC, temperature of the house T8, no? Mas high magini siya kay, heat loss from the house, heat is, removed from the house towards the surrounding. So in that case, Q loss actually is 5,400 kilojoules per degree Celsius. So if the temperature of the house is 21, okay, that's at TH, so 21 minus the temperature of the surrounding. In this case, we don't know yet the temperature of the surrounding. That's TC. We actually tasked to calculate for what is the minimum TC so that our heat pump can still do the pump. No? So ang idea dayan is you need to install a heat pump. Ang heat pump, ingunaan niyang iyahang kuan ba, ingunaan niyang iyahang principle. It's usually attached to an aircon, could be a heat pump if it is operated in reverse. So for example, ato lang ipalayo-layo gamay ang heat pump. Let's have it in red. So naka heat pump diyan, no? Ana lang circle. It takes temperature from it supplies this heat, no? Ginasupplyan nimo heat ang imong balay. Supplyan nimo heat. And that heat, it must balance the heat loss from the balay para ma-maintain nimo ang imong temperature na 21, no? We call this temperature of this heat QH. Anong QH ang tawag na to, ana? Because that heat is supplied to a higher temperature, which is 21. Man agikan nga heat. That's actually being drawn from the surrounding, which is a temperature TC. And we call this now, we call that QC. No? And ang imuhang paano, atong ito lang ni heat pump do, kay basig parihan na siya sa Q. And this can't be done, no? Movement of heat from low temp to high temp can't be done, no, by, naturally. Kay against man siya sa second law of thermodynamics, no? So para mahitabo na siya, we need to supply work. Okay, so gonna supply ka og work sa imuhang heat pump. So in this case, supply work, and this work here is actually in terms of watts. Therefore, rate of doing work, kanang work na gina-supply nato diyan is has a value of 6 kilowatts. 6 kilowatts. Take note na kilowatts na siya. 6 kilowatts. So therefore, we supply 6 kilowatts of work, taking temperature from QC, taking heat from lower temperature, and we're supplying that this temperature QH to temperature 21. Okay? So if we want to maintain this temperature at 21, what must be the value of QH? This must be equal to Q lost. Okay, so therefore kung equal na siya na. By the way, is the Q lost constant? No, it depends on the surrounding temperature. Q lost is simply 5,400 times 21 minus Tc. 21 being the temperature of the hot surrounding or hot of the house, which is at 21. So QH dapat makuha nato ning QH equal to this one. Okay? If we analyze this heat pump now, kanilang heat pump atong lantaw, no? Let's look at the heat pump. Doing energy balance to the heat pump. According to the first law, sagay ng first law sa heat pump, ano din karon? First law tells us that delta U, the change of the internal energy of the heat pump, must be equal to Q added to the heat pump plus work done to the heat pump. Okay? And knowing that this is operating at steady state, delta U must be equal to 0, meaning the change of property of a steady system is really 0. And therefore, Q and W must balance. Now, Q, when we say Q, this is the total heat added to the system. No? A positive Q means heat is added to the pump. Now, when we say system, we mean here the pump, the heat pump. Now, so in this case, QC flows into the heat pump. Therefore, that must be positive, right? QC. However, QH leaves the heat pump. That must be negative. So that's total. The total heat added to the heat pump now is QC minus QH. How about the work? Work done in this case is so let's just try to have work as work palang gihapon para sa yun lang analyze. So nadatay ko naday dapat lang siya daw diri difference, no? Wait lang daw, no? Nada na difference diyan. Difference between the indoors and outdoors. Ang meaning dayani nga kuan is kanang difference ana is actually given by this delta C ng kaning degrees Celsius, meaning in every 1 degree Celsius difference between the temperature of indoor and outdoor, you will be losing heat with this quantity 5,400 kilojoules per hour per degree Celsius difference. Meaning ko ang difference nila is this one, ang heat nga mong ma-loss will be this amount times kung pila ng difference sa temperature. Kung ang imong surrounding, kung imuhang kuan, kung imuhang balay pareho lang og temperature, wala mawala nga heat, right? Ma-maintain na nimo. So Q loss will be 0 if that will be the case. So kanang difference between the indoors and outdoors refers to kaning denominator nimo nga per degree Celsius. Meaning mao ni ang heat na ma-release per 1 degree Celsius difference. So kung dako na ang difference, like in this case wala man dako sa difference pa, no? But we know that the difference between the indoor temperature and the outdoor will be 21, the indoor temperature, minus Tc. So by the way, muna gitawag ato TH, the higher temperature of kanang sa balay. Now from here, we can write this as shall we say QH therefore is equal to work plus QC. Why are we doing this? Now, because we want to again now refer to the Carnot efficiency, because when we talk about minimum, like in this case, determine the lowest outdoor temperature, the minimum temperature, we really assume that our heat pump is operating at its maximum efficiency. In that case, we know that it can only be done if the heat pump is modeled as a Carnot engine or a Carnot heat pump. In this case, we try to look at COP for a Carnot heat pump. When we say COP, the coefficient of performance, it simply gives us an idea of efficiency of the heat pump. When we say heat pump, our desire for operating a heat pump is we want to supply QH. So that's our desired QH. Then over what do we invest? Okay, we input work, or the input work, in that case work. Okay, and we want to relate this in terms of temperatures. We want to do that because gusto na itong ma-express in terms of temperature kay given man tag mga temperature. So daghan ways na in this case, if I substitute QH to be W plus QC, wala ko yung makuha kay dana, no? Dapat ang W ang akong gina-solve ba? By the way, so if we solve W diyan, ba? W from the first law could be written as QH minus QC, right? So, so if we substitute that W from there, so QH over W, which is QH minus QC, we then can now, this ratio now can be expressed in terms of temperature. So, pag nanang kay rate, but ratio ang kailangan nim dili po diha kanang QH, pulihan nimo TH din ng W lang. The temperature ratios can be expressed in terms of temperature, the heat ratio. So, QH could be expressed now in terms of TH, and this QH minus QC could now be expressed as TH minus TC. So, mga derived properties na niya sa Carnot, no? TH minus TC. So therefore, COP, just being the ratio of QHW, must be equal to sama niyang equal. Another value. What is TH in our case? It's 21, but we must be careful nga dapat absolute value, no? So 21 plus 273, that's roughly 294, no? Kelvin, and TH minus TC, that's what? 21 minus, what is TC? Oh, unknown, no? So, sa man, gusto ta, so 294 na lang gihapon, no? We make, since ang ato ang TC diyan, no, kay Celsius man, no? So, therefore, TH minus TC, we will write TH here in terms of Celsius, kay ang TC, atong giasum nga Celsius atong value, no? So, it will be 21 minus TC. Okay, so that's COP. Just being the ratio of QH and W. Now, what are we solving? We want to solve for TC actually. Now, nag-inta ganina nga ang QH must be able to supply the heat loss. Okay? And since QH is known, the heat loss is known to be this one, 5,400, no? 5,400 times 21 minus TC. Okay, 5,400 times 21 minus TC over, what's the work? We know that the heat pump has a constant work input, 6 kilowatts. So, take note here that our values here is in terms of per hour, no? Per hour ato mga values, and so which means itong buhaton, kaning 6 kilowatts ato ning i-convert into per hour, no? Kilojoules per hour. So that's 6 kilowatts means kilojoules per second. So times na siya og 3,600 para mahimo na siya kilojoules per hour. Just to be consistent with our units, that must be equal to 294 over 21 minus TC. And here, by our calculator will give us an answer. No? Negative 13. No? Therefore, TC must be roughly 13, no? Negative 13.3. What can we say about this one? Therefore, this heat pump can work, no? Can be able to maintain this temperature, 21 degrees Celsius, provided that the temperature of the surrounding must not be less than, or must be greater than the surrounding temperature TC must be greater than negative 13.3. Kung mas baba pa sa 13.3 ang mahitabo kay dilan niya ma-supply na nga heat, and kani nga temperature 21 can no longer be maintained, no? By the way, kung nang tanong anong kailangan mo i-maintain ang temperature sa sulod, the reason is some of us don't want to work if the temperature is freezing, or maybe kay mga equipments that needs really proper temperature, calibrated at that temperature, and therefore kung lab na siya yung na proper ang mga equipment na garan man gyud siya at that must be maintained at all costs. Therefore, So unsa man mong buhaton kung ang temperature surrounding kay mas mababa pa sa 13, negative 13. Unsa naman dayon ka? Kung mababa ka sa negative 13.3 degrees Celsius, well, you may now consider maybe adding lain pang ako ano. By the way, heat pump is just one way of adding heat to the system. We could also do it by supplying heat. We can supply heat by electrical, resistance heater. Ang naka-okay lang sa heat pump, take a look. We supply 6 kilowatts of work. Okay? We supply 6 kilowatts of work. Pila man nga heat ang imuhang nakuha out of that. So, kaya mo ng computer, no? Pila galit ni siya sa website. Kung TC, kabalo na ka nga 13.3. Pila man dahil ang QH gonna provide? Sige da, dana sa maximum. 6 kilowatts of work, pila ang QH gonna provide? Therefore, that will just be what? Work 6 kilowatts times 294/21 minus negative 13.3. So, ang value ana niya will be times 6 kilowatts. So, pila ka kuan? Kilowatts. We are actually what? By supplying 6 kilowatts of work, makasupply ta og heat sa imuhang house, sa imuhang system, makasupply ka og heat na, diba 6 lang nino? QH here will be actually, kung efficient kay imuhang heat pump, but of course in reality dili gud siya nga kay efficient, but close to that, 51, no? So 51 kilowatts. Meaning ani, you input work 6 kilowatts, nakakuha ka og 51 kilowatts na, naka-provide kag 51 kilowatts na heat. Whereas kung magamit lang kag electric heater, kung heater imong gamiton daan you supply naka-electric heater diyan na, ang heater kung pila i-input nimo dana na Q I squared R, mora po na nga heat ma-produce. So mas kuan siya, mas efficient, mas tipid ka diyan, But of course, when you have heat pump, this is not a single piece of equipment nga kuana. This needs what? You need to buy the heat pump, you need to buy the working fluid, usually the refrigerant nimo ginagamit, and gina-maintain na siya nimo. While the electric heater is just ditso lang, you just plug it and it's nana siya. So nanay mga difference lang na. Ingon ana ang case. It's either mo palit ba ka og heat pump or electric heater na lang imong gamiton. Dani kay minimum ang imuhang fixed cost. Bato ra maning heater, kaning heat pump na kay maintenance cost over pa na kay mga gina-maintain, then dili ka kung maguba na siya, so minimum magtawag pa kag mga kuan somebody, mga experts to repair that one. So muna ang mga advantage or disadvantage why people are using heat pump. So heat pump gamiton ni siya kung more or less dako imong building, dako imong building man kay sakto nga maintenance. Kung balay lang nimo nga gamay lang kay imong balay, then pahit pa kag heat pump, yung heat pump mas mahal pa sa imong balay. So ayon na lang, pahit na lang ka ng mga heater, palit kag uling something. So muna ang ginabuhat sa uban.